In the skies over the Indian Ocean, just off the coast of Western Australia, a Malaysian Airlines Boeing 777 is climbing smoothly into the evening skies. Everything appears to be normal, until suddenly, the massive airliner starts to lift its nose high into the air without warning. Quickly, the plane starts climbing at an eye-watering rate. At the same time, its speed is dropping dangerously low. Any moment now, the huge Boeing 777 could start falling out of the sky. What is happening here, and will the pilots be able to fix this horrifying malfunction? Find out with me today as we dive deep into a pretty strange case that has an unexpected ending. Welcome to Airspace. On August 1st, 2005, a Malaysian Airlines Boeing 777 departed Perth in Australia for its long-haul flight to Kuala Lumpur, Malaysia. Initially, nothing looked out of the ordinary, and the aircraft climbed smoothly into the Australian skies. After about 18 minutes, while the flight climbed through an altitude of 36,500 feet, the crew suddenly observed strange indications on their flight displays. Abruptly, the side slip indicator drifted fully to the right. This indicator usually shows if the aircraft is aligned with its flight path nicely and is rarely if ever deflected in normal airline operations. But the pilots were left with little to no time to wonder about this strange indication, because the 777's autopilot also started to pitch the aircraft up gradually. Over the next 15 seconds, the plane raised its nose from an initial normal value of 3 degrees to almost 18 degrees. This attitude is usually only reached on takeoff and is highly dangerous at this altitude. Because the air here is so thin, a stall is all but guaranteed if such an attitude is maintained. Baffled, the pilots watched as the nose of the airplane rose further and further into the blue sky above. In the meantime, the rate of climb of the aircraft increased rapidly. Simultaneously, the aircraft's warning system started to issue overspeed and stall warnings at the same time. This is highly unusual and very demanding for the pilots, because the two warnings essentially contradict each other. If this situation sounds familiar, it may be because another flight, Air France 447, also faced a similar situation with catastrophic outcome. When the 777 finally passed an altitude of 41,000 feet, its speed had dropped significantly, from 270 to just 158 knots. With its nose pointing high into the sky, the critical angle of attack was reached and the plane approached a dangerous stall. In a stalled condition, the wings no longer provide enough lift to keep the aircraft airborne. The stick shaker activated, alerting the pilots of this dangerous condition by severely vibrating the control column. Immediately, the pilots reacted. The captain disconnected the autopilot and lowered the nose of the plane. At first, the autothrust system increased thrust, which made it harder for the captain to lower the nose. Since the 777's engines are mounted below the center of gravity, a large increase in thrust will also lead to a nose-up momentum. To counter this, the captain manually moved the thrust levers to the idle position. Finally, the captain succeeded in lowering the nose of the massive airliner. To exit the stall, the captain accelerated the aircraft while its nose pointed down at 7.5 degrees below the horizon, which led to a staggering rate of descent of almost 8,000 feet per minute. After this wild ride, the captain managed to regain control of the aircraft. He leveled the plane off at 38,000 feet after briefly descending to 37,000 feet. Then, he handed the controls of the plane back to the first officer. A few moments later, the first officer attempted to re-engage the autothrust and autopilot. Just seconds later, the plane's computers once again raised its nose to more than 12 degrees nose up, and the 777 again started climbing and losing speed rapidly. Again, the stick shaker activated to indicate to the pilots that a dangerous stall was imminent. Without delay, the first officer took action, deactivated the autopilot and pushed the nose of the plane down. This time, the crew left the autopilot disengaged, declared an emergency, and descended the plane to 20,000 feet. Additionally, they requested to return to Perth immediately, stating that they had severe control difficulties. When they reached an altitude of 20,000 feet, the pilots observed that all indications had returned to normal. Therefore, they decided to attempt to re-engage their autopilots to see whether the malfunctions had subsided too. First, they started with the right autopilot, which immediately attempted to pitch the aircraft up unduly. Also, the stall protection activated instantly, which was uncalled for at this moment. This autopilot was obviously still malfunctioning, so the pilots tried the left autopilot. Unfortunately, this autopilot too still malfunctioned spectacularly. Upon engagement, it pitched the aircraft down and started an uncommanded right turn spontaneously. Finally, the crew decided to leave the autopilots disengaged and flew the aircraft entirely by hand all the way back to Perth. There, the crew was given instructions to land on runway 03. Initially, everything went smoothly, but when the aircraft descended through 3,000 feet, the plane's computers once more falsely sensed a low airspeed and started to increase the plane's thrust beyond what was called for at this time. The captain promptly reacted by counteracting this manually. During their final approach, the crew faced gusty crosswinds, and to their dismay, the aircraft's warning systems also issued a wind shear warning. This warning normally indicates that the wind has shifted dangerously and a loss of airspeed or angle of attack is either measured or imminent. Normally, this calls for an immediate go-around. But, under these circumstances, no longer trusting their systems and not knowing whether the warning was correct or false, the pilots opted to ignore the warning and continued their approach. 1.5 minutes later, the captain touched the 777 down on runway 03. There, one last malfunction occurred. As the aircraft was decelerating on the runway, its auto-brake system slowed it down according to a pre-selected rate. When the captain tried to cancel this braking action with the rudder pedals as it is usually done upon landing, nothing happened and the systems just continued braking. The crew had to actively disengage the system with the respective rotary switch, which is unusual. After they did that, they were finally able to taxi to the gate and call it a day. I'm sure they were glad to have made it back to the ground. While the passengers and crew were able to leave the cursed aircraft behind, the work of the investigators now just began. Why had a seemingly perfectly intact plane misbehaved so gravely that the crash had only been narrowly avoided? To find out, the investigators read out the cockpit voice and flight data recorders, as well as the maintenance computer of the Boeing 777. Unfortunately, the voice recorder was of no use, since it had not been deactivated properly after flight and had just recorded a lot of chatter that happened on the ground after landing. Luckily, the pilots of this incident were still alive to tell the tale, so the team interviewed them instead. The pilots provided the story of severely malfunctioning flight computers in a nutshell, as I have told it to you in the first section of this video. When the analysts tried to verify this story using the flight data recorder, they soon recognized that the story the pilots had told must have been true. When looking at a graphical representation of various flight parameters, one can easily see that the system suddenly went haywire. This happened exactly at the moment the pilots started to experience control difficulties. Let's take a closer look at what happened here. As you can see here, it's mainly these few lines up here that suddenly started to go wild. They represent the accelerations in 3 axes as measured by the aircraft's Air Data and Inertial Reference Unit, in short ADIRU. This device consists of 6 accelerometers, 6 laser gyroscopes, as well as air data units that are not relevant for this case. As the name says, the accelerometers measure acceleration in space along 3 axes, while the gyroscopes measure the rate of change along said axes. You can also clearly see how the aircraft's nose pitched up violently twice, down here. Clearly, the culprit for the strange control commands of the autopilot was found. It must have been the severely malfunctioning ADIRU that output bogus values. But how could it even do so? The system had been designed with great redundancy in mind. After all, the device contains 2 accelerometers and 2 gyroscopes for each axis. A simultaneous failure of both sensors on one axis is highly unlikely. Eventually, the investigators found something astonishing. When they examined the aircraft's maintenance computer more closely, they discovered that indeed, one of the accelerometers had failed just at the moment that the control difficulties began. The analysts were taken aback by this revelation as they delved further into the records. To their surprise, they uncovered a startling fact. The backup accelerometer for this axis had also failed, but it had occurred more than 4 years prior. The implications of this discovery left the investigators questioning the effectiveness of the aircraft's maintenance procedures and the oversight that had allowed such a critical backup component to remain compromised for an extended period. The mystery deepened as they wondered how the aircraft had managed to operate without anyone realizing the backup accelerometer's failure until now. Had poor maintenance been to blame for this incident? When examining the plane's maintenance records, investigators found nothing out of the usual. Furthermore, no mechanic recalled ever seeing a maintenance indication for the ADIRU in question. Then, how was it possible that this accelerometer failure had remained undetected for over 4 years? The truth was finally revealed when analysts took a closer look at the software code of the ADIRU. The code of the ADIRU works in such a way that if it detects that one accelerometer is faulty, it will ignore it and rely on all other sensors. It will also write a status message into the maintenance computer log so that technicians could spot the failure. But due to an error in the software code introduced in an update, this no longer worked properly. While the ADIRU detected that one of its accelerometers failed back in 2001, 4 years prior to the incident, its software never rechecked the maintenance computer to see whether there was a component failure. In other words, the ADIRU never understood that a part of itself was broken, except on the day that the initial failure occurred. This also was never displayed to any technician, so the failure could not have been spotted. On the day of the incident in 2005, a second accelerometer failed, which was immediately recognized by the ADIRU. Doing as it was programmed to do, it now ignored the freshly failed accelerometer and reverted to the backup accelerometer, which it wrongly believed to be fully operational. Of course, this accelerometer had been broken for 4 years and only delivered bogus values, which were accepted by the autopilot system. This system then issued the dangerous nose-up commands. In the end, the manufacturer of the ADIRU fixed this software bug so it should never occur again. Gladly, this incident ended without anyone getting hurt. As the case of Air France 447 shows, this situation could have ended much worse had the pilots not reacted properly and promptly. As you might recall, Air France 447 crashed into the Atlantic Ocean because of contradicting speed and stall indications. I have a video on that if you're interested, but be warned, it's the very first video I ever made. I'll put it in the outro if you're interested. Thank you so much for watching. If you liked the video, make sure to leave a like and subscribe for many more interesting aviation videos. If you'd like to support the channel, check out my Patreon. I have many cool benefits for you for as little as $3 per month. That's it for today. See you all in the next one.